Welcome back to AutistiCoder. In today's video, we're continuing our tree series by exploring breadth-first search and depth-first search, two fundamental traversal algorithms you'll use often in coding challenges. Let's get started. Depth-first search is a traversal method where we start at the root and explore each branch. It's ideal for problems involving connected components or paths. Now that we understand DFS, let's practice using it with an example problem. Find a root to leaf path in the binary tree where the sum of node values matches a target. This is LeetCode problem number 112, a link to which will be in the video description. Feel free to pause the video and come back once you have attempted a solution. Here's my solution to the DFS problem from LeetCode. First, I check if the tree is empty. If the root is null, then there's no path, so I return false. Next, I check if we're at a leaf node and if the value matches the target sum. If so, I've found the path and I return true. Otherwise, I rerun the function on both the left and right subtrees, reducing the target sum for these new function calls by the current node's value. Breadth-first search is a traversal method that explores all nodes at the current level before moving on to the next level. It starts at the root and visits nodes level by level, using a queue to keep track of nodes to visit next. It's ideal for finding the shortest path in an unweighted tree. Before diving deeper into BFS, let's briefly discuss queues and how to implement them in JavaScript. A queue is a data structure that follows the first in, first out principle. In JavaScript, you can use an array as a queue by combining the push and shift methods as shown here. This is a simple way to manage the nodes for BFS traversal. Let's compare DFS and BFS. DFS is best for pathfinding and exploring all possibilities, while BFS is best for shortest path and level order traversal. Now that we understand BFS, let's practice using it. In this example, we'll perform a level order traversal of a binary tree. It's a great way to gather and organize node values by levels. This means visiting each level of the tree from top to bottom, left to right. This is LeetCode problem 102, and a link to the problem will be provided in the YouTube description. Feel free to pause this video to attempt a solution. Here's my solution to the DFS problem from LeetCode. This function performs a level order traversal of a binary tree. To achieve this, I use a queue to track nodes to visit and an array, vals, to store node values level by level. First, I initialize the queue with the root node and start with level 0. In the loop, I process the first node in the queue and determine its level. If the node isn't null, I add its value to the vals array corresponding to its level. Next, I calculate the level for its children and add them to the queue, continuing this process until the queue is empty. Finally, I filter out empty levels from the vals array and return it. This approach ensures all nodes are visited level by level, collecting their values in an organized way. In our next video, we'll explore stacks, another key data structure used in many coding problems. Stacks operate on a simple principle: last in, first out. This means the most recent item added to the stack is the first one removed. Stay tuned to learn how stacks are used in algorithms and real-world applications. As an autistic coder, I'm working hard to provide resources for others in our community who love learning. Your donation can help me keep creating, growing, and making a difference for people like us. If you'd like to support my work, here's how: via PayPal, autisticoder@gmail.com, with my Cash App username, autisticoder, with my Venmo username, autisticoder. Don't forget to like, comment, and subscribe to my YouTube channel, autisticoder. Let's keep learning and growing together.